students, welcome back to Chemical Kinetics. In this module, we will understand what is order of reaction. Like last time we understood what is molecularity, this time we will understand what is order of the reaction. Once again, I want you all to consider this reaction formation of ammonia, that is N2 plus 3H2 giving 2NH3. Now in this equation, if I apply the rate law, I will get the following expression. We already know what rate law is. So I will get rate of the reaction is directly proportional to concentration of N2 raised to alpha into concentration of H2 raised to beta. If you remember, alpha and beta are two exponents which are determined experimentally. And if I add up these exponents, that is alpha plus beta, I will get a value which is called as order of the reaction. So basically, order is nothing but sum of the exponents of the rate law expression. Let's see the definition of order of the reaction. It is the sum of the powers of the concentration of the reactants in the rate law expression. Once again, it is the sum of the powers of the concentration of reactants in the rate law expression, that's called as order of a chemical reaction. Now here I want you to consider this rate law, that is rate is proportional to concentration of N2 raised to alpha into concentration of H2 raised to beta. If you consider this expression, it can also be written by removing the proportionality sign, which means rate is equal to K into concentration of N2 raised to alpha into concentration of H2 raised to beta. So the same expression can be written in both the ways. Now here in this particular expression, K is called as rate constant, or it is also called as velocity constant. We will study about rate constant in the further modules, but right now I just want you to know that the rate law can also be written in the form of rate constant. Now here, if I take an equation, say for example, decomposition of hydrogen peroxide that you all can see on your screen. For this, the rate law expression is rate is equal to K into concentration of H2O2 raised to 1. Now since the exponent over here is 1, I can say that the order of the reaction is 1, which means that it's a first order reaction. Take another example, this NO plus O3 giving NO2 plus O2. For this, the rate law expression is rate is equal to K into concentration of NO into concentration of O3. So you take the alpha and beta, both the values in this case are 1. Take those values, add them together and you will get 2, which means this is a second order reaction. Take another reaction, this one for instance. Look at the rate law expression. Rate is equal to K into NO raised to 2 into O2 raised to 1. Now here you add up the exponents alpha plus beta, that is 2 plus 1, and you will get 3, which means it's a third order reaction. Isn't it simple, my dear students? Now you take this reaction right here, CH3 CHO, that is acetaldehyde giving methane plus carbon monoxide. In this reaction, the rate law expression is rate is equal to K into acetaldehyde concentration raised to 3 by 2. Now what exactly is going on here? If you remember, I told you that alpha and beta are determined experimentally, which means they can also have fractional values. This one, for instance, is a fractional order reaction and the order is 3 by 2, which is nothing but 1.5. If you consider this reaction, decomposition of ammonia at a very high temperature, 1130 Kelvin, in the presence of platinum. This is a zero order reaction, which means that the rate law expression is rate is equal to K into concentration of NH3 raised to 0. The exponent in this case is 0, which essentially means that rate is equal to K. Over here, the value of alpha is 0, which means after determining experimentally the value of alpha, we find that it is 0. So basically, there are two things that we need to understand here. Number one, radioactivity and decomposition are usually first order reactions. Radioactivity and decomposition are usually first order reactions, and the fact that order can be fractional, zero, integral as in an integer, it can have any value. So unlike molecularity, order can have a fractional value. It can be 0 or it can also be an integer. In the next module, we are going to understand the difference between molecularity and order. Till then, take care.